Now, when we have an irrational root, often just leaving the root as is the best we can do as far as reporting the exact value. However, often in real life applications, what we want is an approximation of that value that we can actually, get out a measuring tape and measure or something. And so often what we want is a decimal approximation of that irrational root value. So in this video, we're going to talk about how to get these decimal approximations. We're going to do the demonstration on a TI-84, but any scientific or graphing calculator should have the appropriate functions to take both square roots and arbitrary roots. And square roots and arbitrary roots are usually in separate places on the calculator. You can take a square root with the arbitrary root function just by, entering the index 2. But usually just the square root is easier to access. On the TI-84, for example, to access just the square root function, we press second and then the x squared button. That gives us a radical symbol. We enter the number whose root we want to take. If we want to do any more arithmetic, we press the right arrow to get the cursor outside the root. On older firmware or on the TI-83, instead of putting the number visually inside the square root symbol, the calculator will put whatever you're taking the square root of in parentheses, so you need a close parentheses to end the root. So let's see how we take some square roots using the TI-84. In this first example, I'm asked to give a decimal approximation of the square root of 18. So I press the second key, followed by the x squared key, which gives me that radical symbol. I enter 18, and then I hit the right arrow to get the cursor outside the square root. Notice cursor inside the square root, cursor outside the square root. If I wanted to do any more arithmetic, I would need the cursor outside the square root at this point. But now I hit enter. That gives me a decimal. I'm told to round that to 3 decimal places. So I'm going to give this answer as 4.243. And notice that that does what I want a square root to do. If I put into the calculator now 4.243 squared, that doesn't give me exactly 18 because I've rounded that number, but it gives me something very, very close to 18. Also notice that the symbol we have here is this sort of squiggly equals sign. This symbol means approximately equal. So we'll use that symbol instead of a real equals sign when the decimal we've written represents a rounded approximation. Let's see another example of this. In this next example, we're going to take the square root of 94. So again, I'm going to hit second x squared, type in 94, and I can leave that cursor inside as long as I'm not doing any more arithmetic. So I'm just going to hit enter. Again, rounding to 3 decimal places, I'll have 9.695. And I'm going to confirm again this does what I want a square root to do, right? 9.695 squared. Again, not exactly equal to 94, but very, very close. The reason it's not exactly equal is that this number is rounded. Okay, let's see a couple other examples of what might happen when we do this. We're asked to take the square root of 289. So second x squared, 289. And it turns out that that is exactly 17. It turns out that 289 is a perfect square number, and its square root is exactly equal to the integer 17. Notice if I take 17 squared, I get exactly 289. So if it happens we have a perfect square and we throw it into the calculator will give us the correct integer square root. And then in our last example, let's look at what happens when we try to take the square root of negative 20. We know that that's undefined. The square root of a negative number is going to be undefined. So hopefully the calculator will tell us that. I hit second x squared, and I enter negative 20. Being careful to use the negative sign and not the subtraction sign. Those are different on the TI-84. And when I hit enter, I get an error message. Right? This error says non-real answers. And it says something about being in real mode. We want to be in real mode. If your calculator produces an answer for this, make sure you change your calculator to real number mode for the rest of this class. Now, whenever the calculator gives us an error message, we can say go to, and that'll put the cursor on the thing that's causing the error. Here, what's causing the error is the square root. So we're trying to take the square root of something negative. It doesn't work. That's why the calculator gave us an error message. So the square root of negative 20 is undefined. So that's a square root. How do we take a root with another index? Well, if we want to take the root with any index, we don't have a button on the face of the calculator for it. We have to find it in the math menu. So to take any old root, these are the steps I'm going to follow. I'm going to enter the index. I'm going to press the math button to access the math menu. And then I can either use the arrow keys to select the appropriate option, or I can press the number that corresponds to that option. At that point, I'll have the appropriate radical symbol, and then I can just do exactly what I did for the square root. So let's see how that works out. In this first example, I'm going to take the cube root, that is the third root of 18. So first I'm going to enter 3, that's the index. Then I'm going to press the math key. And the option that I want is option number 5, take any root. Now there's also a take the third root specifically option, but we don't take third roots that often. I'm just going to always use the take any root option if I want to take a root other than the square root. So I picked the take any root option. Notice that the 3 I had entered previously is now showing up as the index of that root. So 3, and then I have this index. I'm going to enter 18 inside the radical. Again, right arrow to get outside. And I get 2.6207. Rounding to 1 decimal place, that'll be 2.621. And again, that does what I want the third root to do, right? 2.621 to the third power. That's very, very close to being 18. It's not exactly 18 because it's rounded, but it's very close. One common mistake I see is people type in the index and then they enter the square root. As you can see, that's a very, very different number. Right? What that does is it takes the square root and then multiplies it by 3. Totally different process. Make sure you're not entering the square root. Make sure you're selecting that choose any root function in the math menu. Let's see another example of that. Here we're going to take the fourth root of the number 21. So I'm going to type in the number 4, go into the math menu and select this arbitrary root option, and then type 21 and hit enter. So the fourth root of 21 to 3 decimal places is about 2.141. And again, that does what we want the fourth root to do, 2.141 to the fourth power. is very, very close to 21. Okay, next we're going to take the fourth root of 81. So 4, math menu, take any root. And this time, instead of scrolling, I just hit the number 5 to select option 5 from the menu. I type in 81. Oh, it turns out I get the exact value 3. So I'm not going to say approximately equal. I'm going to say the fourth root of 81 is exactly 3. Right, so took the fourth root of 81, it turned out to be an integer. I know I have an exact value for it. In this next example, we're taking a root of something negative. Right, we're taking the fifth root of negative 200. This is an odd number, so the fifth root of negative 200 should be fine. Let's see how that works. Right, so I say 5, math menu, take any root, so now I'm taking the fifth root, negative 200. The calculator is perfectly happy about that, right? It gives me an output to 3 decimal places, that's negative 2.885. And again, just to confirm, that still does what we want a fifth root to do. If I take negative 2.885 to the fifth power, not exactly negative 200, but very close. A little bit off because I rounded. In this next example, we're taking a seventh root of a very big number. So 7, math menu, take any root. So now we're taking the seventh root of 995. And we notice that that's actually really, really small. All of these roots have ended up being 2 point something. That's pure coincidence. It's just that, if we're taking like seventh powers, our numbers get very, very big very, very quickly. So the seventh root of 995 is, to 3 decimal places, 2.681. And again, 2.681 to the 7th power. Not exactly 995, but very close. Okay, last example. We want to take the 8th root of negative 215. All right, now this is even, so this 8th root should be undefined. When we throw that into the calculator, so 8, take any root, negative 215. That gives us the same non-real answers error that we got when we tried to take the square root of something negative. So this again is undefined. And when we say go to, right, that shows us that taking that 8th root of a negative number is what's causing the error. So it's nice that we don't need to necessarily know in advance whether or not our root is going to be defined, right? We can just throw it into the calculator. If it's undefined, the calculator will give us an error message. Now, that said, we're going to save some time if we know in advance that this 8th root is undefined. It takes us a little bit of time to throw that into the calculator. But if we don't spot it, the calculator will tell us.